So दोस्तों, we all use ChatGPT, Google Gemini in our day-to-day work. But do we really know how LLM understand things, how LLM works behind the scene? What is a token? What is a context window? What is a prompt? And so on. चलिए हम आज इसको हमें समझते हैं. Let's say you are a new employee or a new student going to your college or going to your organization. तो आप चीजों को या इंस्ट्रक्शंस को समझने में टाइम लगता है. तो आप इसको वर्ड बाय वर्ड मेमोराइज रखते हो. तो व्हाट इज वर्ड बाय वर्ड मेमोराइजिंग? इट इज कॉल्ड टोकन्स. नाउ फॉर एग्जांपल, आपका मेमोरी भी थोड़ा वीक होता है शुरू में, बिकॉज यू आर लर्निंग टू मेनी थिंग्स. दैट्स व्हाई योर कंटेक्स्ट विंडो कम्स इनटू पिक्चर. पुराना चीजें, पूरा 2 वीक पुराना चीजें आप भूल जाते हो. एंड लाइकवाइज आपको इंस्ट्रक्शन कभी कभी थोड़ा रिटेन रखना भी जरूरी होता है, बिकॉज आपको रिटेन इंस्ट्रक्शन समझने में थोड़ा आसान होता है. तो दैट इज व्हाट प्रॉम्प्टिंग इज ऑल अबाउट. प्रॉम्प्टिंग में हम लोग जो है एलएलएम को कुछ क्वेश्चन या कुछ सवाल पूछते हैं, एलएलएम उसको रिस्पॉन्ड करता है. चलिए हम आज तो जानते हैं हाउ एलएलएम और हाउ एसएलएम्स इज एक्चुअली गिविंग अस द करेक्ट रिस्पॉन्स बेस्ड ऑन आवर प्रॉम्प्ट एंड सो ऑन. Now, what is single versus multimodal? Single modal is we give text and the output is, let's say, text. We give, let's say, image. The output is, let's say, image only. So anything of any mode you are giving as the input, it is coming as an output. Okay, that's what is single modal. And you understand what is multimodal. At a time, you can give text, image, and then probably charts. You can give graphs. You can give probably audio, and a lot of things. And multimodal model does is it can analyze all of them and it can summarize. Okay. Foundational model is like how LLM is actually coming into play. Last video we have seen that there is a paper of attention is all you need is attention paper. On that paper, OpenAI works and they have created a huge, large model with, let's say, 20 years of data. All the data, structured data, unstructured data, voice, signals, images, and everything. And it is how the foundational or LLM is actually born. And it is the first model was OpenAI ChatGPT. Okay. And then all the other players, all the other vendors like Anthropic, Google, Grok is by Elon Musk company. So all the foundational models are actually getting there. So what is the difference between foundational models and small language models? Foundational models are the core of LLM. It is how, this particular foundational model knows everything about the internet data. And that's what we call it foundational model as a large language model also. You can see there are some of the names Llama 2, Llama 3, Llama, there is a 3.1, 3.2, all sort of Llama models are there, and they are like 70 billion parameters. And then there is a Bloomberg GPT, Claude 2. Claude is very good for text generation. Then GPT-4, normally you are using GPT-4 or GPT-5. These are the current version of ChatGPT. You can see that for ChatGPT, it is 1.5 or 3 trillion parameters. So what it means is actually we'll understand when we understand about parameters in upcoming slides. But this is how deeper the model is. That means the parameters, tokens, and context window, everything plays hand in hand. It's like when you are cooking, you are putting all the ingredients, and that's how a best dish is actually made. So now let's say, for example, Gemini or ChatGPT 5 is leading the race because their parameters, their tokens, and their context window, everything is playing together very well. We'll understand about all these things. A small language model. Small language models are very important because probably you would see that it's small, it's not that useful, but it is not. That's about text classification. We don't need an image thing. We don't need a sentiment. So we can use a digital GPT. For sentiment analysis, there's a Google Bard small model. That's a very useful model. Okay, same for Mistral. It's a very useful model for a lot of image generation thing. Gimma is one of the very prominent model. 5.3 is the Microsoft 5.3. It's being very useful also for a lot of applications, lot of backend applications. We use 5.3. So these models are tiny, but they are very effective models. And you don't need an LLM for everything. Let's say, for example, there is a model called Clinical GPT. It is for medical purpose. So it is like Clinical GPT. There is a Legal GPT. Okay. There is, let's say, Fin GPT, which is for finance only. You don't have to put all the finance question to the Legal GPT, right? That's how the small models is very effective because it only captures the specific instruction from a specific set of people or specific business use cases. And how they are different between small versus large? Small models are actually million parameters, but large language models are billions or even trillion parameters. It is for simple task. It can handle diverse tasks. So you can create an app over LLM. You can create, I mean, there are a lot of applications are currently being made with using LLMs, and you can make probably one applications. You can create, let's say, website. You can create a chatbot. A lot of things you can use using LLM. It requires a lot of infrastructure, so the cost is high for LLM. It's easier to deploy because it only use small processors, the mobile processors are very small. Your laptop is good enough to compute, let's say, two SLMs. But LLMs are usually, it's hundreds of GPUs are required. It's a very expensive process. And then training required, let's say, weekly or maybe some days data you can use for SLM, not for I mean, LLMs, it requires years of data, or even if, I mean, it's a months of data usage. Now, it is very interesting, like, what is LLM token? Token, you can conceptualize token as set of words. Okay. Why we need token? What is token? I mean, probably you are using ChatGPT 4. The token size is 128K. What it means is actually, let's say I'm just going to give you an analogy over here. Let's LLM tokens are nothing but that. This is a, small chunks or small piece of set of words that is being processed whenever your prompt is actually, getting generated. Let's say these are nothing but your prompts. Okay, all these words. Now, how LLM understand is actually reads your prompt with this small set of words, and that's what called LLM tokens. And also, LLM would give you some kind of output. Okay, it everything comes under tokens, because tokens comprises of your input text, output text, and all the, text. I mean, LLM is actually searched for. Let's say it search for images, everything it requires in terms of how many thousand words it actually processed. It is the set of I mean, tokens it is used. Let's say, just to summarize it, I love India Learns AI's training program. Let's say this is a sentence. Each and every word of this becomes a token, and it's called white space tokenization. So all the white spaces I can divide and I can break it into tokens. Now let's say there are punctuations. So punctuations based tokens can be generated. Let's say Penn Treebank said, like, if there is any apostrophe thing or any sort of that thing, that also breaks in the Penn Treebank standards. There are lot of standards in the tokens. Now there is a concept called, I will tell you, that token ambiguity. What is token ambiguity? Let's say, for example, you are creating a model, and that model is actually trained on Arabic data. So you don't know Arabic as a language. So the language is becoming a barrier over here. Languages have different nuances, different, probably there are a lot of nitty-gritties of each and every language. So tokens cannot be only because of white space or paint driven. So you need to understand what is the right technology to break a word. Otherwise, the meaning would be different. The responses will be bad or worse even. So understanding that language is very key, essential to, going to research for this understanding of tokens, or what all tokenization technique you are going to use. That's the whole essence. So language, token ambiguity are the key important thing under tokenization. What is context window? I mean, it is another very important thing, that it is a span of text that the LLM is actually considered. That means, let's say LLM is going to deliver some kind of an output, but it only sees some bit of, I mean, backend, some bit of text, which is like, say, for example, it will see 10 pages, 10 PDF pages to come up with a response. It might see 1,000 pages to come up with a response. It can even see 1,000 lines. A context window is very key because it is called the memory of LLM. So let's say the LLM is actually here. It is going to give you some kind of response. So how much memory it will use depends on the context window, the size. So now people, you probably have a question in mind, that is it like higher context window is always better or than smaller context window? Because smaller context window will definitely look up to some sort of sentences or some sort of papers behind. The higher is better, but not always. Why? Because bigger context window may come up with lot of noises. There is something called information overload, poor management of data. So more data doesn't mean always good. It can create a lot of noise, redundancy. So not always the information is always bigger information is good. It can be lost data. Management of data is very difficult to have. And there are a lot of, context is coming into picture. because of the higher context window. So probably sometimes, I mean, no context window is better. Important thing in this particular session, which is the parameter. Okay. Now let's say if I give this prompt, what is the capital of India? Let's say I ask like, what is the capital of India? And I give it to, this is my prompt. If I use a mini LLM or a 50 million parameter LLM, now it will give me the capital of India is New Delhi. Here are seven. It stopped because of the less parameter. It cannot give me whatever responses it should give afterwards. So the LLM response is very much dependent on this parameter. So parameters are nothing but an internal thing. It's not something that it doesn't actually represent tokens. It is actually it is the inherent or intrinsic feature of the LLM. The LLM performs on parameters. 7 billion parameter. Here the example of 50 billions or 70 billions parameter, which is let's say Llama 3. Llama 3 model, 70 billion parameter, Queen 50. So see how the responses changes over here. The responses is, let's say, 7 places, and then India Gate, it gave a quick summary one-liner. Then Rashtrapati Bhavan, then Qutub Minar, every point it gives you actually a one-liner. Now let's say you are using a trillion parameter GPT-5. What it gives, it will give you some images also. Some images of India Gate or Qutub Minar, and it will give you lot many context, and it will even give you that which time of the year you should go. So depending on parameter size, the responses are changing. So parameters, so in the parameters, so a lot of important parameters are needed to know. That's a max token temperature. What is max token? So it limits the number of tokens. So let's say if you use max token as probably some thousand, so your responses will change. Temperature is, let's say your temperature is 0.1, and in another prompt you have set your temperature as 0.6. 0.6 is a lot of wild response you will get. So LLM becomes a lot of creativity. It will put on your response. 0.1 or almost like zero temperature is actually the factual data. If I don't have, I don't have. The responses would be on the factual side. If I need a creative response, more sensitive response, I would give, let's say, 0.4 or 0.3. So the temperature is actually factual versus creative. Top P and top K are the very important features, because a lot of chatbots, customer support needs a human touch, needs a emotion when replies. So using top P, let's say 0.1. If I increase to 0.5 for top P, the emotion is actually increases. So depending on that particular, whichever top P is actually good, you need to test your model and then probably put it in the production. So that is what top P tells about. There are penalties also. It reduces your repeat words. So a lot of time LLM responds with the repeat contents, repeat words. So you can use these particular parameters to reduce the repeatability. Stop is a parameter saying that you need to stop here after this. So it can be represented at point one, dot or slash or the end, that type of prompt. I will give you a small, set of example in the description section with all these parameters. But just before that, you see that, let's say I have used max token and stop in a different color code. So with this color code, you understand that if I use max token, let's say with some thousand and then probably stop, then it is actually limiting feature I want to use in the parameter. Let's say temperature and top P. If I use both of them, it actually signifies that I need the model to respond in more creative or more human touch way. So that is how you can play around it with this particular parameter technique. So the color code is actually nothing but the combinations you can use. You can use these two together to limit your repeatable words. ये वीडियो अगर आपको अच्छा लगा तो आप इसको लाइक करना मत भूलना, शेयर करो किसी एक के साथ, और इंडियन एनसीआई को सब्सक्राइब करो।